So, hello everyone. Today I'm going to present you how we made tracing easier in OpenEdge. Yeah. So, for starters, I'm going to introduce. I'm Justas Poliakas. I came from Vilnius, Lithuania. I feel like a real youngster in here. Most of you have more experience than I have years in my life, so mine. I'm representing a really great company, Baltic Amadeus. It has a long history in IT. It has a long history in working with Progress, OpenEdge. So we have implemented plenty of projects. We have a lot of customers, and most of our customers can recommend us. So if you need anything related to IT, you can contact me directly or our company, and we will sort it out. So let's get the boring things out of the way. I guess for most of you, it's going to be already known things. So let's get into it. What is tracing or traces? So traces are basically directions of your program. So tracing literally means mapping your program. Why do we trace? We trace to simply understand how our program works and how our application can be better, or where are the problematic places. So how do we trace in OpenEdge? There's basically two ways where we can meet traces in OpenEdge, one of them being error call stacks, which are kind of traces, but they make no real use in monitoring because we got an error. That's already a problem. And another one would be profiling. So if we talk about profiling, it's a way of measuring your code's or application's performance dynamically. So in order to profile, you have to instrument your code with a tool called Profiler. So Progress has a profiler in its tool stack. So to introduce Profiler, for those who don't know what it is one of the basic OpenEdge tools. It's really easy to use. Using it, you can evaluate the performance on OpenEdge's code, and there's not many of tools that can help you do that in OpenEdge. Also, Profiler's output and results can be viewed in OpenEdge Developer Studio natively. An example of how to use OpenEdge's Profiler you can see on your right side of the screen. So what is this all about? What is this presentation about? So we, me and our team, thought that there must be a better way to measure and monitor your code's performance and map your code. So we decided to create a tool to help us do that better, at least better than Profiler does. So why? Firstly, OpenEdge's Profiler is not that convenient to use. The fact that you have to use Developer Studio for it is already a limiting factor. It runs only on Windows. And it doesn't show the complete trace of your program. It only shows summaries and some levels of the traces, which is not that helpful unless you have an obvious problem. Also, it has really limited and outdated documentation, which is really hard to find, and if you find it, you cannot rely on it 100%. Well, also OpenEdge profilers differ from Progress version to version, which is actually an issue if you run one version in production, and let's say you have newer versions on your machine, you cannot view that file unless you hack it somehow. Also, it's the only way you can view the results. So I guess every one of us might have a grief on OpenEdge, so let's keep them for ourselves. So we wanted to create a tool which would provide us alternatives to the standard tooling. We wanted more flexibility in ways we should and could work. Also, we want to provide the possibility to trace your application's request from the user interface, from the user interaction to the database and back, which is not available with current OpenEdge tooling. And also, it's really hard to automate monitoring of your application's performance using current OpenEdge's profilers solution. So what we have considered to implement, there you're going to see an acronym OTEL, which is OpenTelemetry. Don't think about it too hard right now. I'm going to present it later. So many of you might know that OpenEdge can inject .NET's code into OpenEdge's functionality. And we thought that .NET already has an OpenTelemetry library, so why don't we inject it into OpenEdge? But it's not that easy. Also, we wrote and thought about writing a custom OpenTelemetry library natively in OpenEdge, and then we thought about writing a parser for a tool that's already existing in OpenEdge. So basically, we thought to write a profiler output files parser. So some of these solutions passed, some of these failed. We have implemented both of those solutions, whether it's to write a custom OpenTelemetry library or to write a parser for profiler. And just trust me, don't try to inject more complex .NET code into OpenEdge. It doesn't work. So today I'm going to present to you an OpenEdge profilers parser. Let's talk about why. So in our opinion, this parser is easiest to maintain and write, easiest to deploy to existing code because you basically don't need any additional code in your code base. You don't need time on that. You don't need to risk changing your logic, and it almost does not interrupt your application's performance, almost. And obviously, it's easy to adapt because it's a small and portable tool, so you can do whatever you like with it. So what are the benefits of our tool compared to standard OpenEdge tooling? It's easy to use, it's really fast, it's portable between operating systems, whether it's Windows, Unix, or macOS. I guess you can even run it on some mobile platforms for whatever reason you might need it, because it's written on Golang, and wherever the Golang is running, you can run it. Obviously, when you have more than one tool to review the results, you have a lot of flexibility in filtering or slicing your data. It is, or it could be, a centralized solution depending on what you need. For example, if you have multiple applications running and you need to analyze all of them, you can direct the parsing of your all applications profilers output into one place and view it there, or you can simply run it on your machine and do whatever you like. As I've said before, we wanted to enable automation.
I have a question from Ken Herring. Could the OpenTelemetry implementation coordinate easy with Dynatrace?
I guess, but I don't have an answer to that. So yeah. So where was I? So we wanted to automate, and we achieved it. It's easy to use our tool because it's basically a command line tool to automate whatever you like. we can provide the full trace from interaction to the progress database or any database that matter using OpenTelemetry standard and tooling. And one of the more important things for us was that we can support all of the latest progress versions, which is a big deal, at least for me. And we can use whatever the results viewing tool for our liking. So how can we apply this tool in practice? As I've said, it almost does not disrupt performance of our application. And I said almost because we know that Profiler takes its toll on the performance of the application. Sometimes it's quite a measurable decrease in performance. Sometimes it's negligible. So if it's one of those cases where you feel that higher threshold of application performance disruption, you can apply some smart policies. Let's say you trace 1 every 10th of your application calls, or you trace 1 every 10th second. If you need to understand what's going on every call, you can apply it on every call, but keep in mind that performance might not be okay. And you can you can enable this profiler only when some issues occur and until you resolve those issues. So what are the shortcomings of it? Directly of our tool, we haven't found any shortcomings because it's a rather easy and light tool. And talking about shortcomings, I would say that the biggest griefs that we found related to the profiler itself is that it only measures time in microseconds, which is 1 to the millionth, while our modern processors are working on and it's a nano. So some simpler applications can happen in 1 microsecond, and then you might run into some issues because you have to trace the order that OpenEdge or Progress Profiler gave you the results, which is not that consistent as you might think. So what are we going to offer next from our side? We are working on cooperation with White Star Software to provide a native integration of our tool with their amazing tool Protop. And also we are working on providing a framework which would allow to a lot easier provide policy rules to our code. So remember when I talked about how to apply it in practice, I talked about applying different policies, so we're working on implementing them. So now let's have some fun with OpenEdge Trace. I guess everyone has already seen the profiler's output file in person and saw plenty of tiny numbers, and they simply doesn't make sense at first glance. You need to really dive into, find some documentation. So we did, and one of the more interesting facts about the trace block of that profiler. So there you can see the trace that OpenEdge provides us. And when you think about it, it makes sense, but you try to read it through, and then you see a negative code line in your code. How is this even possible? After some investigation, we figured out that it's a garbage collection, which should work always the same, but it provides different numbers because it's a garbage. Yeah. Also, the pinnacle of this trace tracking is a 0 or the initial code line of your project or your code. So when you encounter a 0 code line on the trace, it has the start time of your code object, which is fine. But the interesting thing is that this trace line is being displayed at the moment when your object is constructed. So basically, all of this timing data is sorted this ascending, and all of a sudden you have a 0 code line which is out of sync. And at this point you understand that you cannot alter that sequence of trace block because you're going to lose the possibility to trace. We have had an implementation which was based on the start time of code lines, but we ran into problems when we encountered some objects which happened at the same millisecond. Microsecond, sorry. Yeah, and another interesting thing is that, which at first seems rather strange, that there's no 0 code line neither for destruction nor creation of the initial program that you enabled profiler in, which at first seemed strange. Why? How? But on the second thought, profiler cannot know when that program was created because it's enabled in it. The same goes for the disabling profiler. So just before we jump into the demo, remember I told you that I'm going to present you OpenTelemetry. So what is OpenTelemetry? It's a vendor-neutral standard or an agreement between different developers and applications to communicate in a common standard between them. And OpenTelemetry works by injecting some of OpenTelemetry library into your application's code. In our case, we came around it without a need to inject directly into code. We can use a tool to observe default progress output, and then this inject of our application sends the data to OpenTelemetry collector agent, which communicates with telemetry collector service. So OpenTelemetry supports 3 main pillars or metrics of your application, which are logs. I'm currently about traces. My colleagues in previous years at groups have talked about log metrics of your program. If you want to know about that more, just look in the archives. So in order to view the results which our parser provides, you should use some kind of trace. We have tested our tool with Jaeger, Zipkin, and Grafana. Jaeger is the most popular trace receiver. Grafana is not an actual trace receiver, but I guess at least some of you are using Grafana for other purposes, so you can easily integrate tracing into Grafana by selecting Jaeger or Zipkin as a data source for it. It's important that you can use pretty much any kind of trace receiver as long as it supports OpenTelemetry standard, and you will not need any code changes to send it to different places. So I have talked about tracing a full request of your application. So this is a graphical representation of it. So imagine you have a user interface which is written in some JavaScript and transcribed into HTML and so on. Then you can instrument it with default open source OpenTelemetry tools for JavaScript. The same goes for middleware, which might be written in Node.js. Then for app server, which in Progress case is written in Java. And then for OpenEdge, we had a gap there. And this is where we, with our tool, come in. And then there's a database where, in case of Progress, it's a protops territory, and we are willing to integrate with them. So how this our parser works? It's a rather simple tool and process, so I'm not going too deep into this area. So basically, we read a profiler's output file, we streamline it by saying delete what is not interesting in tracing. We create that main blocks creation and destruction, and then we simply parse it. Parsing is pretty easy. If you would like to get into more detail, you will be able to see the code, and then we sort. So finally, something more interesting, right? So let's see a demo. I'm not going to do an actual demo because we had some bad luck with it today. I'm going to show you some static images. So example of how to apply profiler's boilerplate to enable profiler, then run your code and disable it. So in order to turn it on or off, you simply need to change two lines. Profiler enabled, change it to false, and profiler profiling, change it to false. That's it. And it will be shut off. So in this demo, we have a procedure which is called main-p, and this is the contents of it. So it's a really simple procedure which simply is thinking about how to show some traces. And there is a code which should draw two branches of a trace, one a little bit longer, another a little bit shorter. So after running OpenEdge's code, we get this kind of profiler's output, which is gibberish unless you really know what to look for. And this is not too much of a use for us at the moment, but we can pass it to our profiler parser tool. And there you can see an output that it's calculating a call tree, black box, right? And then it's sending that data to a trace receiver, which in our case is Zipkin. And when we go to the Zipkin home page, we can see that we have a demo service. In that home page, we can see all of the history of our previous traces, and we can sort it by the duration, by the amount of spans, start time, and so on. And this is important because you can already see in a plain eye if your service is starting to get slower or faster, and you might want to look into details why. So if we go into that demo service, we can see a full trace of the program, and we can visually see representation of time, what part took what amount of time. So I've marked the branches that our demo application created in arrows in red, and the same goes for the timing for them. So this is how we made tracing easy in OpenEdge. And if you want to see a code, it's an open source code in GitHub. So simply go to the link, or if you don't trust shortcuts, just go into GitHub, Baltic Amadeus, OpenEdge, profiler, parser, and there you have it. Do you have any questions? That's great. Thank you.